Hello friends, in this video will be the topic of graphs and will propose a way to find the optimal path between nodes by using Prolog. The theory of graphs originates from the 18th century, where it was sought to cross the 7 bridges of the city of Königsberg only once each one of them. The Swiss Leonhard Euler was asked by a youth committee in the city for help. After a few months, Euler presented a report showing the impossibility of the route. He then published an article in which he solved the problem in the general case. The published article was considered as a birth of graph theory. There are many techniques for finding paths between two nodes, even with nodes that relate to each other, with edges that have weights. The article shows the number of links and the weight of these links are used when applied to network. Also, not always the shortest route is the one we need. When it comes to traveling to a city we do not know, this is where the current map system intervenes, which are very good at recommending the shortest routes, but failing not recommend a route that is emotionally pleasant. The following figure is show a clear example of the graph. This graph represents a fact in Prolog. It is formed by two nodes A and B, one edge with weight 5. In other words, it explains that there is a connection from A to B, but not from B to A, due to direction of the edge.
Now I will explain our program. As you can see here, we have already created a graph with nodes and edges between the nodes. Each edge has a weight, and now we try to find the best possible path between two nodes. Let's say we want to go from node A to node G, and we click the button and it says that this is the best path according to the weight. The way we do this is we generate a Prolog file that we can then consult to the Prolog file to find out which is the best path to the end node. And as you can see here, whenever we click on this button, it generates the Prolog file, and it tells us how many nodes we have, the source, the target, and the weight. Source A, target B, source A, target B, and the weight equals 3. And then we save this to our Prolog file, and it comes out something like this. We say arc from A to B is 3, arc from A to C equals 2. This rule right here we use to calculate the best possible path according to the weight. And as you can see, we can add another node, let's say a Z node, and we can create another path to it. We can add a weight, and then we can generate again, and if we reload this file we can see that it has created another node. Now if we want, we can say we want to go from node G to node A, and it's actually not possible because as you can see the arrows point to where we can go. For example, we say we want to go from node G to node A, from here to here. G can go to node Z, Z can go to node I can go to B can go to D, but it's actually not possible to reach node A. If we say we want to go from node G to node F, that's actually possible. We click on Analyze, and as you can see, the row that is giving us is G, Z, I, B, D, E, and F. Now let's say, for example, we want to go from node F to the same node F. That will also work. And the result that it gives us is F, G, C, I, B, D, E, and F. And we have reached the same node. So this will only work for directed graphs.